Here minus 4x plus 6, and it has roots alpha and beta. So if it has roots alpha and beta, it has to calculate the value of alpha squared plus beta squared. Now, I don't know how to calculate alpha squared plus beta squared, but this is what I do know, that the sum of the roots of any quadratic equation, alpha plus beta, is equal to minus b over a. All right, where b is the coefficient of the x term and a is the coefficient of the x squared term. All right, so I'm just going to put down the equation over here and show you how we decipher that. The equation is x squared minus 4x plus 6. Now this equation is where you know your coefficients of your x squared term, your x term, and your constant. From this equation, a equal 1 because the coefficient of x squared is 1. And this is saying b equal negative 4 and c is equal to 6. All right, so you're going to need to know these formula in order to be able to can work out the sum and the product of the roots. So alpha plus beta is minus b over a, and so minus 4 is positive 4. So that's alpha plus beta. Now the product of the roots alpha beta is equal to c over a. Alpha beta is c over a. C over a is 6 over 1, which is 6. Now look at what they're asking for. They're asking us for the value of alpha squared plus beta squared. So this is what they want us to calculate, alpha squared plus beta squared. Now look how we're going to find this. To find this, I'm going to go back to this. What is alpha plus beta all squared? Alpha plus beta all squared. How would you expand this bracket? To expand this bracket, alpha plus beta all squared would be alpha squared plus 2 alpha beta plus beta squared. This is how we expand that bracket. All right. But now, guys, look what we do now. We know that alpha plus beta is 4, and so alpha plus beta all squared is going to be 4 squared. That's equal to, we don't know what is alpha squared, so we write that back. Alpha squared plus 2 alpha beta. What is alpha beta? Alpha beta is 6. What is 2 times 6? 2 times 6 is 12. Plus beta squared. So alpha squared plus beta squared, we can find that now. Look at this, alpha squared plus beta squared. Yeah. If we bring over the 12 over here, so 4 squared is 16. 16 minus the 12 is 4. And so 4 is equal to alpha squared plus beta squared. And that's the answer. 4 is equal to alpha squared plus beta squared. And this gets rid of part 1. Nice and easy, soft. No real issues. Now the second part of the question goes further by asking us to find the range of values for x, for which 2x minus 5 over 3x plus 1 is greater than 0. Now let's look at the second part of the question. Now the second part of the question, when you're solving this inequality, when you're solving a rational inequality, the first step is to convert it to a quadratic inequality. To convert it to a quadratic inequality, we're going to multiply both sides by the square of the denominator. So right here, when we have this, we're going to multiply both sides by the square of the denominator. So we're going to multiply both sides by 3x plus 1 all squared. That's the first step. You multiply both sides by 3x plus 1 all squared. What that will give you is 3x plus 1 all squared times this result in 2x minus 5 times 3x plus 1 is greater than 0 times anything is just 0. And so there, that's how we convert it from a rational inequality into a quadratic inequality. All right, and this is a quadratic inequality we have. Now, I always like to draw a sketch before I write down my solution. Just like to draw a sketch of a quadratic graph. Sketch of the quadratic graph, and the roots would be 5 over 2 and minus 1 over 3. This is what the roots would be. 5 over 2 would be here, and the minus 1 over 3 would be here. This is the roots. All right, think of this as f of x greater than 0. And then we know that f of x equals 0. This would be the line y equals 0. But they're asking us for when this is going to be greater than 0. It's going to be greater than 0 out here. This is where the function is greater than 0 out here. So the function is greater than 0 when x is less than this value or when x is bigger than that value. All right? Nice and easy. So let's do this. So let's write down our solution now. Our solution then, right? Our solution is going to be x is less than minus 1 over 3. Minus 1 over 3. X is either less than minus 1 over 3 or x is greater than 5 over 2. That's the solution. X is either less than minus 1 over 3 or x is greater than 5 over 2. And that's the solution. Nice and easy. Soft. So far, nothing biggie, nothing too tricky. Everything nice and easy. Okay, now let's look at the next part of the question. Part 3. Part 3 is a sequence and series question. Let's hear what they have to say. They say that a customer is doing what? It says a customer repays a loan monthly by increasing the payment each month by X dollars. It says if the customer repaid $50 in the 5th month and $70 in the 9th month, calculate the amount of money repaid by the end of the 24th month. So notice what they said. They said that in the 5th month, so the 5th month, so the 5th, I mean, like to use common letters, the 5th month payment, as we can see, that was $50, all right? And it said that in the 9th month, the payment was $70, all right? And it says each month, the payment increased by X dollars, all right? So the monthly increase is equal to X dollars, all right? But clearly we can decipher what the monthly increase is already, because if it's increasing by X dollars, in the 6th month, you pay $55, in the 7th month, you pay 60, 8th month, 65, 9 months, 70. So clearly we can decipher that X is equal to 5. We've done that already. X is equal to 5. All right, so X is equal to 5. So each month you're increasing the payment by $5. So pretty much, since we know that we were increasing the payment by $5, we can tell what is the first month payment. The first month payment, as we can see, would therefore be 50. In the 4th month would have been 45. In the 4th month would have been 45. In the 3rd month would have been 40. In the 2nd month would have been 35. In the 1st month, so the 1st month payment, would have been equal to just $30, right? So to find out how much you're going to pay at the end of the 24th month, then this is a sequence question. You can do it two ways, and I'm going to show you both ways. The first way is to say that the sum, I like to write S for sum, the sum of the first 24 months pay is a sequence question. Remember, sum, before I even write sum of the first 24, let's just write down back the formula for Sn, because it's a sequence. Sn is equal to n over 2 times 2a plus n minus 1 times d. All right, so this is the formula for Sn, and as we were saying now, you can replace n with 24 because it want the total amount that you're going to pay for 24 months. So it would be S24 is equal to 24 over 2, which is going to be 12, times 2 times A. A is the first monthly payment, so it's going to be 2 times A. A is 30, so it's 2 times 30, plus n minus 1. N is 24. 24 minus 1 is 23. And 23 is then multiplied by the monthly increase, which is 5. And this will give you the sum that would have been paid for the first 24 months. So we work this out, we're going to get 12 times 2 times 30 plus 23 times 5 times 12. That's $2,100. That's the total amount of money that would have been paid for 24 months, $2,100. That's method 1, all right? That's method 1. As we all know in mathematics, there's always multiple ways of doing it. So this is method 2. This is for the lazy persons, method 2. Since it told us that it's increasing by $5, we could have said that the sum is equal to first month payment 30 plus second month payment would have been 35 plus 40 plus 45 plus 50 plus 55 plus 60 plus 65 plus 70 plus 75 plus 80 plus 85 plus 90. Now, how many months would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Plus 95 plus 100 plus 105 plus 110 plus 115 plus 120 plus 125 plus 130 plus 135 plus 140. How many is that now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, plus 145. That would have been 24. Now, you add up all of these and that will give you how much money is paid over 24 months. So 30 plus 35 plus 40 plus 45 plus 50 plus 55 plus 60 plus 65 plus 70 plus 75 plus 80 plus 85 plus 90 plus 95 plus 100 plus 105 plus 110 plus 115 plus 120 plus 125 plus 130 plus 135 plus 145. Ooh, so much adding. And you'd have gotten your same $2,100. All of that for that. Nice and easy. So either way, you check it out, you get your $2,100. All right, so as I was saying, method 2 is more for the lazy persons that can't bother to remember this formula. And method 1 is the proper way to do it. So this is this question. Nice and easy, soft. That takes care of question 1. Let's go to, well, that takes care of section 1, not question 1, section 1. Now let's go to section